Alright guys, we will make a start. Today what we're going to do is introduce electrical engineering to you. So we've gone through the other three disciplines and now we've got electrical engineering. As we've discussed, you've got your subject next semester that actually details electronic circuits and electrical engineering properly, but this is your introduction to the field. So what is an electrical engineer? I'd like to introduce Don McPhail from Ergon Energy. He's going to talk about electrical engineering and also some scholarship opportunities that are out there for you guys to actually apply for. Alright, so I'll hand over to Don.
Thanks, Dave. Alright, good morning everyone, and thanks for having me here to present. So as Dave mentioned, I'm going to be talking about electrical engineering and sort of what that entails. I guess just to give a quick background, as Dave said, I work for Ergon Energy. I'm a network strategy and policy engineer with Ergon, and I've been with them since I graduated from University of Queensland in 2008. So just on what I was going to talk about today, I was just going to go through what is electrical engineering, where electrical engineers work, what are the opportunities out there, both in Australia and global, and sort of my journey to date. So I guess just to kick things off, I'm not sure if people have seen this before, but this is just a little, I guess, video I remember seeing in my first year from the comic strip Dilbert on the knack or the curse of the engineer.
I'm worried about little Dilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh. The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I'd want to run an EEG on him, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The knack?
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical, and utter social ineptitude.
Can he lead a normal life?
No. He'll be an engineer.
No!
There. Don't blame yourself.
So just something light to start with, but so in terms of electrical engineering, there's three main streams. There's power engineering, which I'm involved in, electronics and power electronics, and telecommunications. And I guess sort of the definition of electrical engineering as per Engineers Australia is it's involved in the research, design, development, manufacture, installation, operation, maintenance and management of equipment, plants and systems, which probably sounds like most engineering in general. So I guess just sort of touching on where the electrical engineers work, one of the biggest employers, or the big employers in Australia, the complete supply chain of the power industry. So you've got everything from generation, both fossil fuels and renewables, through to transmission, distribution, the metering, telecommunication, operational technology systems, right down to the household end user. The other one that's the really massive employer is obviously the mining industry for engineers in general. The other couple of things that Australia does well is also the consumer power electronics industry. It's not a massive one compared to other countries, but we have a sort of a niche market of products. And then the other ones are the Defence Force is a huge employer, which has all sorts of challenges, and then a rail and electrification of rail. On a more global scale, there's the aeronautics industry employs a colossal amount of engineers, and there's the other ones are telecommunications, the sort of space and satellites programs, manufacturing and automation, and then all the big vehicle manufacturers, as well as companies like electronic companies such as like Apple, and then the big sort of switching gear and all sorts of specialties like ABB, Siemens and GE. I guess what are the opportunities for an electrical engineer? They're sort of, I guess, endless and global depending on where you want to go and what your interest is. As I was sort of saying, within Australia, it's really around the two big employers are the power industry and the mining industry. And this is probably just reflective of the economy that we operate in, this sort of old world technologies. We're not a sort of a leader in mass manufacturing and that, which is sort of represented by the downsizing of car manufacturing and that. But we do have that sort of niche market where we create highly skilled products quite well, such as like the bionic ears and eyes and that sort of stuff that we've done a lot of work in. And then the sort of products that come out of CSIRO that are commercialised, which sort of leads into that small-scale electronic design and manufacturing. And then telecommunications, there's a lot of stuff that has to be done locally to build up a telecommunication network. And that's one of those industries where it is a massive expansion because everything needs telecommunications. Even the power industry and mining industries are expanding off the back of telecommunication, investing big amounts in that area. So sort of, I guess, power industry is a state of change. Mining is more power and control monitoring systems for supporting the mining operations. That electronics one's the specialist, and the telecommunications is sort of a bit of a boom in capital growth. The other sort of ones is operations and asset management, which can be a massive sort of anything that has an asset. There's electrical engineers usually involved, product developers and vendors, consultants, specialist problem solvers, which can even be in things such as insurance companies and so forth. You've got communication control systems. So if you take, for instance, the rail network, say in Brisbane, there's you need the operational technology that basically monitors, does all the switching and that sort of thing. Can control where the trains are going and make sure there's not a head-on collision, but they can travel at the high speed with the high volumes to support the drivers and the customers. And then you've got the manufacturing, which is now shifting to a greater emphasis on automation and efficiency. So before, where there was a lot of stuff that was done hands-on, it's an increasing amount where it's trying to use control systems and that sort of thing that can take away the human element and have it done by robotics and other sort of automated systems. And then agriculture is a massive one that's not so big at the moment, but will grow again with telecommunications in that with crops. There's so much we can do now with using weather data, with automation of the watering systems, the fertilizer systems, knowing exactly the right time to harvest and to fertilize. And then with say livestock and that, when you're talking about areas the size of medium-sized European countries for cattle stations, there's tagging and gate control and all that sort of stuff that's starting to be used now to start moving those sort of that livestock around, as well as get them through shipping yards and sale yards as well. I guess sort of just touching on my own experience as an engineer. So I graduated from UQ in 2008. I then was on the Ergon Energy graduate program from 2009 to 2011. From 2011 to 2013, I worked overseas for 2 years on the ES Cornwall Scholarship, which I'll touch on a bit later. And then since I've been back in 2013, it's been more of a transition to senior engineering type disciplines and getting things such as my chartered professional engineering and becoming a registered professional engineer of Queensland. So just on a graduate program, so the Ergon Energy one's pretty typical of a lot of the big companies, like the mining companies and so forth. Basically, it's a program where each year they take in so many people. I'm sure you're aware or have heard of these sort of things. The fourth years at the moment would be starting to go for their sort of interviews and that in the near future. But basically you have the pool of graduates in first, second, third year sort of thing. You have managers that will be their manager for usually a rotation of sometime between 6 to 12 months. And then you have mentors that'll stay with them throughout and help sort of coach and guide them throughout both professional development and personal development. And there's a lot of, I guess, training in there as well around both technical skills. So there's a lot you learn at university, and then when you arrive on sort of day one, you feel like you know nothing, because it is a sharp learning curve. Once you start taking what you've learned in books and crammed and remembered for that one exam, and then forgot the next 20 minutes afterwards, then starting to apply that on real things and seeing how different formulas and all that actually apply. So then usually it involves, for me it was involved going around through different groups, each spending 6 months. So I worked in the protection systems, network planning, then I got to work out in the field for 6 months with the tradies with what's called the substation operations and the distribution test teams. So they sort of construct and maintain the Ergon Energy substations. And then I went to the commissioning control systems, the communications and control systems group, And then last I was with the alternative energy solutions, looking at the connection of customer PV and battery systems on the grid. As I was saying, there's a lot of training in that you get to usually take part as part of the graduate programs, and for me that involved doing a number of sort of electricity supply type courses as well as personal development ones, which are around, you know, everything from negotiation skills to conflict resolution to you know, managing people, all the sort of things that are, you know, very important when you're trying to play a part in an industry. And then I guess the other thing that comes with these, you know, once you graduate, there's the opportunity to, if you take initiative, to go to conferences, to present and to attend and learn from, you know, the experts. And for me, there was other sort of internal extracurricular things where we had like forums where we'd come together as all the graduates, because we'd be spread across the state, exchange, you know, information, learn from the other mentors and managers that we wouldn't see otherwise. And then also getting to do site visits, as well as within our job going out to sites and that, but also, you know, going through the control centre or the call centre or the, you know, substations or generation plants, or going remote to communities and stuff like that, all just trying to understand the different challenges that as an electricity utility that we face. So just on the experience with the scholarship, so the ES Cornwall Scholarship is something that's offered to any Queensland electrical engineering graduate who's been working for somewhere between 3 to 5 years, and it's offered usually about every 3 years. It was originally set up as a sort of a trust run by a man named Ergon Cornwall, who was very much involved in setting up the electricity industry in southeast Queensland, and when he passed away, he left all his money to this scholarship. So it's been running for about 80 years now. And what it involves is you go, someone's receives it once every 3 years, and you get to go work overseas for 18 months to gain a heap of industry experience that you wouldn't have been able to get otherwise in Australia, and then bring that knowledge back to Australia. So I got it in 2011, and my I guess focus of my work was around distributed energy resources and electric vehicle infrastructure, and how we integrate that in the electricity distribution network. So I first worked with in London with UK Power Networks, which is the utility for London, on their Low Carbon London project, which is their sort of smart grid trial program. Then I went to DNV Kema in the Netherlands, and was working around they're a consultancy, a very large consultancy across the world, and Netherlands being their head base, and it was around the sort of the integration of electric vehicles and distributed generation and demand and energy storage on the grid. And then the last one I went to was in the States, working for EcoTality, who at the time operated the world's largest electric vehicle charging network. They had over 12,000 charging stations around the US. And actually in Phoenix, where I lived, there was over 500 charging stations in the city. And my work there was involved around looking at energy storage, electric vehicle charging, and how you can couple them up, as well as demand response. So, I mean, I guess this is just something I thought I'd throw in there, in that, you know, there is a lot of opportunities even from early on, that if you wish, you can, you know, it's a global profession, and the degree opens you up to global opportunities. And I guess some of the highlights for me in doing that was I got to go to the Olympic Park in London when it was getting constructed. My manager was involved in doing the whole electricity supply solution for the Olympic Park, because it had to have so many fail-safes so that it would definitely not lose power when the whole world was watching that event. It couldn't afford not to be able to have the lights on in the stadium, and so for all the people being able to report on it. So that was, you know, really interesting to see that all come together, just because there were so many different types of engineering involved. And I guess the other one was in the States with the electric vehicles, and that they were trialling, and they were the independent testers for the different alternative fuel vehicle in the US. So I was going to, you know, trial and see them getting pulled apart and all that sort of stuff that they were doing as part of their testing. So it was really interesting sort of being in that sort of forefront of technology that's coming through, that especially in Australia that we aren't seeing at the moment, but out the US, you know, you'd have to be spending sort of 40 grand to see that sort of stuff up close. And then since I've been back, I guess the first focus was on one of the things you need to be an engineer in Queensland, regardless of whether it's, you know, electrical, mechanical, mining, civil, environmental. You need to be a registered professional of engineers Queensland, which is run by the state government, and it's basically a register to be able to sign off on any drawing standards, projects. It's just, I guess it's a legal requirement. So there's a certain amount of development involved to get to that, and one of the avenues is the CPEng program through Engineers Australia. So you have to be a member of Engineers Australia, but over sort of 3 to 5 years you go through and prove the number of competencies that you need to be classed as, I guess, a professional engineer. And then once you have that, then they do an interview and a sort of an assessment of your skills and capabilities, and then you're eligible for RPEQ as well. So it's kind of, I guess, within a lot of companies in Queensland, it's often a prerequisite that you have your RPEQ once you get to this sort of level of engineering. Either have your RPEQ or working towards getting it within the next sort of 12 months or something like that. And it's usually around that sort of 5 years out of uni that starts to become a requirement. And that's just all tied back to legislation that protects the consumers and the customers and the people of Queensland. The other thing I've been involved in was a program manager for Energy Sense communities. So in Townsville here, there was a smart grid trial program that was run mostly in the Bowley area, and it was around sort of deferring the having the need to build 2 new substations out there by using smart grid technologies, which can be basically putting telecommunications into the network and starting to use smarter switching devices, being able to analyse the individual pieces of plant to push them harder, or knowing, instead of making assumptions, knowing exactly how it's operating to operate it efficiently, as well as doing things such as demand management programs with customers, hot water, tariff trials with them as well. And it was all sort of around just working the network more efficiently, using either smarter business models and smarter technologies. And I guess this also was used to shape the way that we'll run the network across the state going forward. And the other thing is, I'm the network strategy and policy engineer, and a big focus has been on inverter energy systems. So an inverter energy system is anything such as PV, solar, batteries, wind, hydro, anything that connects to the grid via an inverter. And there's sort of, at this stage, the biggest one has been solar through things such as the solar bonus scheme and that. But it opens up a whole heap of challenges for the grid, because it's now energy coming back into the grid from the customers as opposed to always going one way. So it starts to change the dynamics of how we operate the network. And I guess a big piece of work lately has been Ergon and Energex. We've developed a joint standard that would be the connection process and set around the protection requirements and so forth for any customer, whether it's your mum and dad or a small business or anything like that wants to, or a hospital or a church or something that wants to put on solar panels or a wind turbine in their backyard, or battery systems, and how that connects to the grid and how that operates safely. So I guess the one thing I sort of want to say was then that within engineering, one thing I always thought was that it was all around the sort of technical, the mathematical, the physics. There's all these sort of very engineering type challenges. And while a lot of stuff that I face in my day-to-day is around trying to address those technical issues, I think one thing I've learned is that the technical element is often quite easy to solve. It's all the constraints that go around it that are non-technical. And I guess sort of one of the, I think, things that takes up a lot of the time within Ergon now is, we're trying to face all these sort of technical issues that we're seeing from PV and batteries and so forth being connected to the grid. But looking more further forward, there's the issue that with all these PV and battery systems coming in, the way the pricing structure is, the way that people pay for electricity, they'll be using less electricity, which then means, because we're a regulated utility, the government decides how much we earn, and then the electricity prices reflect that to pay off the assets. If there's less volume of electricity sales, then we have to increase the price across that smaller volume, which means more people go and get PV and batteries because they want to reduce their electricity bills, which means the price has to go up again because there's less volume but still the same number of assets. And you have what this in the industry is called the price or death spiral, because as that keeps happening, you get less and less people, and the people that eventually are stuck are the lower income earners, the people that can't afford the investment to go out and buy that PV or battery system. And And that's all because, so it sort of is I guess a lose-lose, because the people that even go out and put the PV in battery systems would have bought a solution that was more expensive than what would have happened if, collectively there was the grid. So there's a lot of, I guess, industry changes, market tariff changes, the way that the utilities operate and all that. That needs to change fundamentally now to make sure that it all stays as, a low-cost solution, that people that are low-income earners aren't disadvantaged in that. So I guess while there's the technical issues, I'm just sort of saying that there's so much more that goes above it that really usually is the thing that's driving the direction that we take and the solution that comes out. And it's about sort of balancing the technical solutions to meet those constraints. And I guess one of the ways that sort of touching on the technical stuff that we're addressing things is that, say with the inverter energy systems, is we've done trials of different smarter inverter technologies so that we can then include in our standard to make it the new norm for industry. We've also looked at the solutions that we address on the network side of things, such as different devices such as StatComs, utility scale battery systems, and low voltage regulators to help manage the grid more intelligently but at a lower cost to meet those sort of challenges that we get. And then also being proactive and trialling things such as electric vehicles to understand what the challenges will be, both from a technical and managing customers, so that we can be ahead of the game. So it's all these sort of things, I guess, that, trying to play catch up as well as play at the same time with the challenge as well as being proactive. That's sort of the balls that have to be juggled. And ultimately, I guess we're always looking forward to where do we want to head, and what sort of path and reform do we need to take to get there. And I guess, from the electricity industry is sort of, we've got the house on the left there, which is the present day, just looks stock standard Queensland house with the stock standard car, and then in the future, it could be standard to have PV, electric vehicle. They've got storage in the basement. They've got a smart meter, which is then connected to a home energy management system. They don't just have a flat price tariff, they've got time of use tariffs which have different price depending on the time of day. They've got smart heating and cooling systems, and it's all trying to manage all this complexity that comes in, but provide, I guess, the best technical and economical solution. So just I guess just touching on my own journey going forward now. So I guess what I've done to date and where I want to keep on going, because I guess you're always looking to continue to develop and where the opportunities within the industry can take you. And for myself, I want to continue to get further experience in engineering and program manager roles to keep developing my technical skills and that oversight on managing challenging and large programs. The other thing is then also looking to get so that senior engineer and management roles, to taking on that greater responsibility. And I guess as part of that, I've now started having my own graduates and vacation students that have started working for me as well, which is a great opportunity to then start passing on the same things that I gained when I first entered the industry. In terms of postgraduate study, that's it's quite common then for, I guess, people to go back and do either a master's or a PhD in engineering, or doing something like an MBA or something like that within the business sphere. I guess one of the differences between Australia and say Europe is in Europe it's sort of stock standard that to get your first job you have to have a master's. That's the entry level requirement, and even then people still may wait 18 months to find their first job. I guess we're fortunate in a sense in Australia that engineers are in high demand. You can walk out of a bachelor degree and either have a job already lined up or find something in sort of 6 months. And so I guess it's sort of being aware of that, if there's such highly skilled people in Europe, that we have to start thinking about, they might want to start moving to Australia and taking advantage of those opportunities, and making sure that as a person we're always competitive in our abilities and we're able to competently do our jobs. And I guess there's always the opportunity, even though, not being on a graduate program or anything, being a professional engineer, to look to swap with a colleague or something for sort of 3 to 6 months to get their experience in what they do, and I guess to become a more well-rounded engineer. And as you sort of move up, you need to know, I guess, a broader field, but you know less about it, and so it's being able to competently do that as you move up. And I guess the other sort of, opportunity that's open to any engineer at any point in their career is the Engineers Australia local groups that are a great way to, be in contact with engineering outside of your profession. I guess within the power industry, it's pretty well 90% all electrical engineers. There's a small amount of civil engineers, but you only really see power-related engineers, and it's a good opportunity within those sort of Engineers Australia bodies to get to start understand the sort of the civil issues, the mechanical issues, the electrical, the mining. So I guess, you know, developing well-rounded skills as well as the contacts and the networking that's needed to help get better solutions in that. So, and actually that's probably something, just touching on that too, as students, it's free to become a member of Engineers Australia. And often a lot of graduate programs are tied to the Engineers Australia CPEng program, so they'll pay for your membership as well for those first couple of years. But it's a good way to, because it is free, to you know, to do some professional development and get courses, to meet, you know, potential employers, and I guess really start to get involved and take on sort of a leadership role as well that can be beneficial when you start to apply for jobs, to point to, you know, your involvement in the industry. And I guess saying, you know, what do I like most about electrical engineering, but this is probably broader to all types of engineering. I guess the biggest fun for me is the opportunity. Within engineering, it's sort of open to whatever path you want to, you know, take it down. There's so many, it's such a broad spectrum once you've got engineering, and then even when looking down to a single discipline such as electrical, there's still, you know, power, mining, electronics. And then, you know, drilling down into, let's say, power, there's still, you know, operational technology, control systems, there's planning, there's substation design, there's commissioning, there's all sorts of, I guess, individual little bits that you can find the opportunity within, both in Australia and global. I think, you know, going back to what I was saying before about those challenges, I think that's part of the thing that makes it interesting, is those challenges. You know, technical is a big part, and you're expected to sort of be innovative in your solutions, but there's also, you know, the political, the financial, the timescales, the consumer, you know, the resources available. They're all sort of things you have to juggle to find the best solution. And it is an area where there is constant change, and you are sort of at the front of, you know, new technologies, new developments, and that sort of thing, and I guess aware of and participating in things that the general public wouldn't otherwise get to, given the access it sort of opens up to you. And I guess, you know, the big one is that as engineers we provide a service. You know, we I guess tying back to many years ago sort of thing, a bridge between Ayr and Home Hill basically opened up the north for what was available to be accomplished. It was you know, it majorly changed the shape of North Queensland, and the same is then said when, you know, electricity came through and started being able to provide the type of services and businesses. And then even now in modern day, the sort of telecommunication networks that's going over the top of it, being able to provide real-time health services to people in remote areas, to be able to provide, you know, smarter working electronic systems, and that, be able to, you know, provide bionic eyes and the cochlear implants and all that. They're all sort of things that are providing a service to the community and changing the way we work. And even the smallest, you know, engineering role plays a very pivotal part towards all that. And I guess, yeah, I think the other thing is the change. It is constantly changing because technology, you know, anything you learn today is, you know, or the type of technology used today is irrelevant in 3 years, it's outdated and that sort of thing. It's something that means that as an engineer, because we're at that forefront, it always is going to be constantly changing. And sure, there's the the underlying physics and mathematics and even base products that stay the same. There is that sort of top level that's always constantly changing, which keeps it, you know, interesting and fresh. So I just want to then sort of talk about the scholarship that Dave mentioned that is available to first years in the power industry. So it's offered by the Australian Power Institute, and they offer this to every year across the country. And I sort of talked a bit on that, but I guess there's sort of, you know, it's set up where there's all the utilities within the power industry put in a certain amount of money, and then it's distributed as a scholarship or a bursary to first years, and it helps go towards, you know, the cost of tuition and you know, textbooks and so forth, as well as finding vacation placements and that as well, and even to an extent helping with finding that first role. But it really puts, I guess, you know, a sort of a label on you to help you getting a job just because you have that, you know, that bursary. Sort of a lot of this is just touching on what I said, but I guess one of the things they're saying that, you know, wanted to point out is that sort of a lot of the big common topic discussions at the moment are about, you know, climate change, are about the manufacturing industry scaling down, are on like how do we adapt to be relevant in sort of this Asian century or Asian economy century. You know, where does CSIRO go? With ARENA being, you know, potentially reduced down, what does that mean for us as an innovation? If we want to be, you know, a leading agriculture provider, how do we do that and compete with low wage cost countries like Brazil? So these are all sort of challenges that I guess engineering opens up, and power industry plays a big role in that. So a lot of this I just touched on. I'll just jump to the power. So the bursary program, so open to first year engineering, but there are occasions where second and third years get it as well. The major has to be in electrical, although they often do take mechanical or mechatronics or infomechatronics students as well, but with that sort of focus on ending up in the power industry. The bursary program has a wide variety of sponsors, as I said, each of the utilities and even some of the manufacturers. And then basically that means that all of them are sort of an invested interest in seeing you do well, and you know, getting a vacation placement with them, and then potentially a role afterwards. And they really are trying to look at getting the next generation developed. So what's in it for you? There's an $8,000 payment over 4 years. So it starts from the day you receive the bursary. I mean, they say there's no strings attached, and there's approximately 40 bursaries available this year. You also then get the opportunity to get vacation placements from the end of your first year, so potentially you could get one at the end of first, second and third year, having, you know, 9 months experience by the time you graduate, and you know, the person that you might be going for a role against might only have 3, so it puts you, you know, right at the front there of the job pool. They'll also, when it comes time to do your 4th year thesis, they'll help you find a thesis topic with a industry partner, which again helps you develop that relationship with that company, but also means that the thesis topic that you work on is for a challenge or a problem today that is going to be used within that company, and there's a massive variety of things that have been done. I've seen things from the mining industry where the thesis that someone did resulted in a colossal, like several $1 million saving just in the way that they were able to improve something in the efficiency of changing tyres on the big trucks and that. So there is a lot of, I guess it has that real world relevance today sort of thing. And then of course networking opportunities. You're meeting your fellow bursaries both in your year and future years, as well as, you know, those managers and the representatives from the companies and the bursary program coordinators. So there was the flyers that went around as well to get to the link and that, and to find out how to apply. The closing date is 31st of May, which is the end of next week, so there's not very much time to apply. So anyone that's interested in ending up in the power industry or as an electrical engineer, I'd strongly encourage to apply, because it is a pretty simple application. And then sort of just saying, as I did, that's all of the power industry utilities, plus a lot of the big manufacturers like ABB, Wilson Transformers, and that are all sponsors of the bursary program. And the selection criteria for the bursary is it's based on your tertiary entrance results, so your high school results, and then your first semester university results. And I guess they want to see people that are interested and motivated ending up in the energy industry at the end. And then it's limited to Australian citizens and permanent residents. So that includes my presentation and the talk on the bursary as well. Happy to take any questions or anything like that as well.
Any questions? Anybody electrical engineers interested in a little bit more information? I have a question. So with the London Stadium, what sort of redundancy type of systems did they have in that to make sure that the power was staying on when someone was running an important race?
Yeah, so it was, so normally within the electricity industry, you have like either a N-1, so if one thing fails, it'll still work.
Yep.
But in there, it was like a 3 times N-1, so you kind of had like almost 6 times redundancy.
Yeah, right.
And the size of the energy going through, whereas, you know, our cables might be this big in Ergon territory, it was like massive cables sort of thing, and all underground substations, so the cost of it was also in like the billions of dollars and that sort of thing. Yeah. So historically it was a terrible area. It was a very low socioeconomic industrial, not as somewhere you probably walk through the day, let alone at night. And now it'll have the best electricity supply. It's also got a heating and cooling system all through it. Yeah.
Excellent. Questions? you?
With regards to more environment-friendly energy, I know Europe is big on wind turbine power because the geography of the land and stuff tends to work well with it. In Australia, is there any consensus about actual industry-funded solar plants as opposed to trying to get push on all individuals to get solar?
Yeah, there's been talks at different times. When Anna Bligh was Premier, there was a big push then for a very large solar plant in Queensland, which ended up being scrapped then when the Newman government came in. And that was going to go somewhere in the Chinchilla in southwest Queensland. But there's still a couple of big ones going in now into New South Wales. And then there's sort of like, I guess, medium, well, still quite small in the several hundred kilowatts that are going on top of like the hospital in Hervey Bay and some other places. And then the Defence Force is looking to put, even just here in Townsville, I think it's like 1.5 megawatts. So it's all still quite small in terms of, you know, the size of gigawatt size coal power stations and that, but it's a step. I guess in terms of wind though, there's a fair bit of wind in Victoria and South Australia, but in Queensland as well we've got the issue where, especially up here, where the wind will blow very strong for a very short period of time of the year, which means all the turbines turn off because they can't spin that fast, and then there's no wind, so it's kind of just not a choice here, but yeah.
Other questions? Up to that?
Programming.
They're just rounding out their MATLAB subject.
Okay.
Challenging projects.
Yeah. I guess historically, most of the people that probably work in the power industry would have had no programming experience, or if they did, it was with punch cards and stuff like that. But that said, if you can do it doesn't have to be complex, but if you can do sort of really basic programming in like Visual Basics and MATLAB, it can really make the sort of analysis that you do quite quick and efficient. There's also, like within the power industry, there's modelling packages that sort of give a geographical layout of the network with all its, you know, conductor types, the customers, the loads, the generators, everything, and it runs the analysis for you. So you sort of have to be able to interpret it, but it does all the computational stuff behind it for you. So it's very, you know, user friendly in that regard. So I guess in short answer is as little as much as you like is probably the depending on which direction you want to take it. But it has its benefits, I guess.
Aside from solar and wind, are there any other renewable energy technologies that, like, become power stations stop supplying?
Yeah, there is ones. So I guess one of the big ones that's like being investigated at the moment is geothermal. There's an old geothermal plant in Birdsville which is 100 years old, but in South Australia there's a massive investment in a plant that's kind of in the middle of the Northern Territory, South Australia, Queensland, New South Wales sort of central point that all those states meet, which means there's no loads nearby, but it would supposedly produce enough power at any time to power 5 Australias if they wanted to tap into that amount. But the cost of getting a transmission line there is probably the thing that's
biggest thing.
Yeah.
Do you guys all know what geothermal is? So basically dig a big hole and send water or whatever down past the hot rocks and use that steam to then drive a turbine?
Yeah, and actually in this spot too, the water is so like high pressure in that too that when they first tapped it, they didn't have to add any water to it. They just sort of had to close the loop because it was all just sort of
it was already doing
spewing it out. Yeah, but then you've got the solar and the wind, and then there's, I guess, there's there's about 3 different wave power generation plants in Australia now that are still very, you know, phase 2 commercialisation things, so there's still probably about 2 more steps they need to go, but they'll still be quite small. There's tidal ones where they put them in rivers and that as well, and as the tide comes in, all the water goes up, and then they'll hold it up there, and then as the water goes back down, they'll release it and they'll turn the turbines and that, which is kind of what we do with some dams and that around the place as well. But in Australia it's a bit limited, but say in New Zealand they have tons of hydro power stations because of all the snow melting off the mountains and the rivers flowing quite fast and that as a result.
Other questions?
What's that, sorry? Favourite type? I can't say that I have a favourite type. I think maybe, I mean, I'm always interested by the ones that are sort of almost a little bit science fiction, and because they're not, you know, realised today, and that there's a lot of really interesting ones you hear of that are still lab type ones, and they have really interesting proposals of how great it'll be and that sort of thing. But it's, I mean, it's renewable energies is one of those things where it's not going to be like coal or gas or oil, where it's just one power plant is going to supply all of the country's needs. It'll have to be a sort of a patchwork of all different sorts, and I guess that's one of the challenges is shifting from these massive centralised power stations to having these smaller distributed ones and playing with things that we don't necessarily have much control over, like we can't control the time of the sun, but we can predict the type, you know, we can't control the wind, but we can make some predictions around it. Geothermal and those sort of things we can sort of throw up and down a little bit, but yeah, I guess it's no one silver bullet, I guess, yeah. Sorry, yeah. At Ergon. At Ergon, I believe the number is going to be 8 this year, and historically it's been somewhere between about 6 and 12. I know last year they didn't take any just because of company restructure and that sort of thing, but I think going forward it'll always be about 8 from now on. That's sort of the plan. And that's predominantly electrical. I think it's 1 civil engineer each year.
Anyone else?
All right. Whoever. What's that, sorry? Oh yeah, sure. So there's a number of different ways to sort of manage the overvoltage. I guess the prevention is the best method. So first, when we have someone apply for PV systems and all those sort of things, or a diesel generating plant, we'll do an assessment and say, based on the network, this is the biggest size that can go in. If, however, we've got the issue now, there's things like regulators that the voltage comes in at one side and then it just sort of changes the number of windings on the transformer to change the voltage coming out the other side. And they can be dynamic in that, doing it in real time without disconnecting the power to do it. There's things called stack cons, which are like a static VAR compensator, which so you've got real power and reactive power, and it changes the amount of reactive power to sort of either bring down the voltage or push the voltage up depending on the need. And then you've got things like batteries and that can absorb or export real power as well as absorbing and exporting reactive power. So at the low voltage end of the network there are a few options, and in the high voltage there's also then like capacitor banks and inductive coils and what that can help manage the voltage as well. Is there another question there? Did you have a question?
Is there an easier type of power to work with, or are they same?
Like you mean the generation type things? Yeah. I mean, for us, it's all really the same. We sort of, because the interface is either through like an inverter or some sort of protection system or something like that. It's all, I guess, a lot of the challenges are being worked through. With the small scale stuff, it's because it's a changing industry, and they each impose. I guess with solar PV, one of the challenges that we have in residential areas is that the generation's there during the day when no one's at home and there's no load. So it's sort of like a double whammy in that there's no one using the power, and it makes the challenges harder for us in that as well. But if it was on during the time of load, it would be a massive benefit. So.
You're talking about the grid and more people get batteries.
Yeah.
Is that a lose-lose situation economically only, or would that be a win-win?
No, so batteries in themselves are probably one of those ones where it could be a win-win for customers and the utility. I guess the one I was thinking of is the where you got more generation plants such as PV, wind and that, and it's reduced the amount of consumption. But I guess batteries just take energy from one generation. Batteries take the energy generator at one time of day to be used for another time of day. So it can be a win for the utility and a win for the customer in that regard. The problem is the commercial side, and as it stands today, there's really, based on the price and that, there's just no financial reason why someone can justify putting a battery system in. And I mean, we might be looking at 2017 or something like that where it starts to make sense.
Because the more people that get batteries, the more it does that really come. Is that correct?
Well, it depends. If they have a generation source, then that's true. They can generate their energy during the day, say if it's from solar, charge the battery and supply the night, that reduces the need for the grid. But what will probably happen then is that the grid will still be supplying that. I mean, the grid's built to design to supply that 1 hour of the year that is the absolute worst case scenario, and then we have to pay for it for the rest of the year. And with things such as air conditioning loads and that, and pool pumps, and so many people having them, it really went from being the worst day to the average was, you know, not a very, like say, a 50% increase, to the worst day to the average being sort of like a 200% increase. And with that average constantly reducing and the peak constantly going up, it means you have to keep building something for a network that sits there most of the time doing nothing. It's kind of the equivalent of if the road network was built to supply that one time of the day or the year where all the cars were on the road and driving around, and the rest of the time, every time you hopped on, there's like a 20-lane highway with one car driving around, sort of thing. There's a lot of changes that need to happen within the industry, not so much from a technical, but from a political and regulatory to accommodate that sort of thing as well.
Current battery technologies are horrendous as well, aren't they?
What's that, sorry, Dan?
Current battery technologies are terrible. They're incredibly expensive and notoriously difficult to get power on and off, and longevity and things like that, aren't they?
I mean, if you bought a battery system, you're looking at somewhere between, well, I mean, depending on if you install it and do all the best practices, you're probably looking at somewhere between 8 to 10 years at best, and then you have to replace them. Yeah, then you have to replace. There's all sorts of safety issues around, like, you know, based on the knowledge of the people that usually install them. They're not usually experienced in installing battery systems and that, so there's all sorts of fire and electrical safety issues. Yeah. But yeah, the cost of installing one, you'd have to be off-grid already with a diesel generator and maybe a PV system, and the only reason you're doing that was to try and reduce the amount of diesel that you're using. It just really is super expensive at the moment.
Generally, rural properties and things like that have a tendency to have battery systems if they're completely off-grid. But I've seen them. The ones that I've seen have been in containers, so like shipping containers full of batteries, and incredibly expensive systems.
That's right, and sort of the ones that we would use in the grid are like the smaller one would be a half a shipping container. Yeah. They're still pretty massive to provide meaningful difference. Yeah.
Absolutely.
You can still get it if you're doing, as long as the, I guess, the main focus is towards electrical, but they'll do mechanical and electronics and that sort of thing. Oh yeah, that's fine then. Yeah, I don't think the amount of money though changes though. It's still like that sort of capped amount, even if it takes you 5 years to do the degree. Yeah, but that's no worries. I've known people that have done a maths and engineering one and still got it.
Yeah, excellent. All right, any other questions? Great. All right. Well, thanks, Don, again. I'm just going to take a minute to tell you about the quiz, but sure. Then we'll be done. All right. So, no tutorial this afternoon. We discussed that in the last lecture. Basically, that room is available to you guys for 3 hours if you would like to work on your project. Otherwise, use the afternoon wisely. That's due next week. Everyone should be a lot of the way through their design. Now, next Thursday is our quiz. Next Thursday is quiz 2. On quiz 2, everything that we've done after quiz 1 could be on it. So, for example, questions relating to what is electrical engineering and what might a project be that an electrical engineer works on. So you've had a lecture today about that, and I've also said that you can go and find some YouTube videos and things like that in your own time to investigate a little bit further on electrical engineering. What is mechanical engineering and the sorts of projects, and you've had quite a bit of experience with that by now, hopefully. Project management, so that stuff we did last week in the lecture, that in-class hand-in, and also drawing. And I've put up 3 past exams on LearnJCU. Disregard the first, or half of those exams. Half of those exams are on drawing and project management. Those are the bits pay attention to, because those are the type of questions you might be asked in an exam. That answer may be isometric drawing, isometric sketching, that kind of thing. But that's what's going to be on this quiz. All right, so on Thursday, and then Friday I will be talking about what's on your exam, how to study for exams, and we'll wrap up the entire semester. Cool? All right, thanks everyone. Have a good weekend. All right.